Hi guys, welcome to our lesson for today. So today we're going to be focusing on a heading that says inverses functions, right? So the main thing here is to try and look at how do we see that an inverse is a function, right? Because we're still using the same concept of a vertical line test that we've been talking about. But before that, let's just look at our mind map and see exactly what functions are about, and then try to answer this question that we have here. So firstly, remember we've been talking about the different types of functions that we have. We've been looking at what an inverse is, goes hand in hand with what we call logs under exponential functions. Our notation of functions is very important for you to please remember this, because it is what determines whether you understand what you are talking about or not. Now, our keywords here will be a function and also an inverse function, right? Remember, a function, just a quick recap, is a relationship that is a mathematical between two variables where we know that every input value must have only one output value. And then we have two types of functions, a one-to-one and a many-to-one. Now, a one-to-one simply means that one input value corresponds with only one output value, right? And then with the many-to-one means that you can have many input values, many inputs, which will correspond with one output, right? So you please need to make sure that you are clear on that, right? So normally when they show you this, they normally do something like this, where they say this is input, that is output, and then arrows like this, right? To say that this is a one-to-one function, right? And then if it's a many-to-one, then you will have input and then output. Then you can have this input going with that output there, both of them, and then maybe have this one going with that one as well, both of them, things like that, right? So maybe -2 and 2 will go with the same value, and then other values will go with same values as well. So it's just such things that you need to make sure that you are clear about. And then an inverse function is a function that can reverse into another function, right? In simple terms, this is just the opposite of that particular function. So if we were to swap things around, what function will we get? That's what an inverse function is about. And this process of swapping or interchanging things is said to be a reflection of a function about the line y equal to x. And then an inverse function is normally denoted by the symbol f to the exponent of -1. And then they can also just say into x like that. It really means one and the same thing. Now, an inverse function is therefore formally defined using this particular expression here, or equation, where whatever that was, let me just erase this because I want to show you exactly how this definition comes about. Whatever that was an x becomes a y in the inverse function, and then whatever that was a y in the original becomes an x in the inverse function, right? And this is solely because of the equation y equal to x, because you swap things around, right? So there's this word they normally use which says interchanging. In simple terms, it's just to swap around values. Now, an inverse function is normally found by, number one, interchanging the x and y value. And remember, I said interchanging is the same as swapping things around, right? Swap them around. And then making y the subject of the formula depending on what function you have. If it's an exponential, making y the subject of the formula will require a log. If it's a linear, the inverse function will also be a linear. And then if it's a quadratic, the inverse will also be a quadratic. And then lastly, if it's a hyperbolic, the inverse will also be a hyperbolic function, right? That doesn't really change much. The only thing you just need to make sure you remember carefully is the concept of logs, right? And then you write the final formula in the form. But this is mainly if they had asked you to actually write it in this form, because most of the time they say in the form of y is equals to something. Now, we have what we call the inverse of a one-to-one function, and then later on we'll look at the inverse of a many-to-one function. There are two types, there are two functions that are actually said to be one-to-one. It's the linear one and the exponential function, right? Linear one, you know, this is just like that. So all the time, one input value will always go with one output value. Even with the exponential graph, it can be something like that. So if I use my vertical line test, then you know it will always be just at one point. That's what one-to-one is all about. Now, let's just try and look at a specific question on how to go about doing this, right? So here they're saying to us, consider the linear function f of x is equal to 3x minus 1, right? If I'm given this, and then the first question wants me to find what is the inverse of this particular equation. Remember that you will need to interchange the x and the y, right, in order to write down this function here, right? So you firstly interchange them, and then you make y the subject of the formula. So this will simply just be x plus 1 equal to y, and then you know that 3y, then you'll divide both sides by 3. So when you do that, this is what you will then have as the inverse function of this particular equation that we have here. And then the inverse of an exponential function, what this is all about is we obtain it still by the same rule, but now we need to apply the logarithms, right? So we firstly need to quickly just try and look at how do we go about with the conversions. Remember, if you move from exponential, you will get to logarithmic function as the inverse. And then if you move from a log, you will get to exponential as the inverse. So it's a vice versa thing. A log gives you an exponential gives you a log. And that's how you then look at the concept of how to convert between these things. Now here we are given that f of x is equals to a to the exponent of x, which passes through the point 2 and 1 over 9. And then the question says we must prove that a is equals to 1 over 3. Just remember that to prove that something is something, it means that you just need to show me the process of how did it become 1 over 3. And for you to do that, you will simply just need to substitute the x and the y value and then try solving for what you are seeing there. And if it is possible for you to solve it, by all means go for it. If not, then maybe you will need to apply a log or something like that. So with this one, let's substitute the point that is given to us and see whether we can do what they want us to do. So this will simply be, I know this is 1 over 9 is equals to a to the exponent of 2, and then just remember this is a, not 9, and then I will need to find the square root on both sides, and then a will be equals to plus or minus 1 over 3, but please remember that a cannot be a negative, right? So a must always be greater than 0 rather. It cannot be 0 and it must always be greater than 0. So in simple terms, this will be a is equals to 1 over 3. And now what they will want us to now do is to determine the equation of the inverse in this particular form where it's y is equals to, right? Just to remember what we need to do, which we interchange the x and the y. So this becomes x is equals to 1 over 3 to the exponent of y, and therefore this becomes y is equals to log of x base 1 over 3, right? And that's what you will then need to do in order to find this equation. And by the way, they said in the form y is equals, if they had said in the form f to the negative 1, then you will need to write it like this and say log x base 1 over 3, if they wanted it in this form. And then that's what you therefore need to make sure that you understand about this concept of inverses. This was mainly inverses of one-to-one functions. When we come back from the ad break, we're then going to look at inverses of many-to-one functions and some concepts that go hand in hand with those particular inverses. But for you to know this, you need to come back just after this ad break. Please stay tuned. I'll be back just now. Hi guys, welcome back. So we are still looking at the concept of inverses and trying to look at whether these inverses are functions or not, right? So we looked at the concept of inverses of one-to-one functions. Now we need to look at the inverse of many-to-one functions. A typical example of a many-to-one function will then be a parabola, which is normally considered a quadratic function, right? So firstly, let's look at whether the inverse of a quadratic equation is actually a function or not. If not, how can we then make it a function? Because the goal, remember, is that for a function for a graph to have an inverse, it must be a function, right? And then also the inverse must also be a function. And how to go about doing that is what we're going to try and look at now. So consider the many-to-one function that we have here, which is f of x is equals to x squared, right? This is a quadratic equation. We know that to draw this, we will use a calculator if we need to, but just because we already have this table, we're just going to quickly do it here, right? But for interest's sake, I think I will show you how to do it here, and then I will quickly show you how to do it on the calculator. So this is normally going to be minus 2 all squared, which is equals to positive 4, minus 1 squared is equals to 1, 0 squared is equals to 0, 1 squared is equals to 1, and then 2 squared will be equals to 4. Now you can see the whole concept of many-to-one is because, you see, many inputs correspond to one output value, which is normally 4. You see, you don't necessarily need to show both of them, you can just show one. And then 1 and negative 1 also go with 1, you see, which is down there as well. So you can see that, let me do this so that you can see that they are the same thing, right? Now on the calculator, how to go about doing this on the calculator, we will then need to say, our function here is alpha x squared is equals to, we start at negative 2, we end at positive 2. Our step is always going to be 1, and then you can see. For negative 2, I have 4 as what I have on the board. For minus 1, I have 1. For 0, I have 0. For 1, I have 1. And then for 2, I have 4. And that's what I will have on this particular calculator. So it's really one and the same thing. Now on the Cartesian on a Cartesian plane, to plot this, 0 goes with the 0 there. 1 goes with 1, so 1 will be somewhere here, which will go with 1, which is somewhere there. And then negative 1 will also go with 1. Negative 2 goes with positive 4, so it's there. Positive 2 goes with positive 4. And then to join this, it will simply just be something that's like that, right? It's just not drawn to scale. Maybe let me just try to draw it a bit more to scale. I know it's going to erase the whole thing. So if I draw it a bit more to scale, my graph will look something like that, right? And then if you draw it using the proper scale, then it will look like this. Now, what we then need to now do is to find the inverse of this. Remember, the inverse of this is all about reflecting the line about y is equals to x, right? So you interchange the x and the y, which will need you to then solve for a y here. So to do that, I will find a square root there, find a square root there. Therefore, y will be equals to plus or minus the square root of x, right? Because this is all about a plus and a minus, meaning it's above the x-axis and below the x-axis. Now, what we want to do so that we can compare the two graphs, we want to draw these two graphs on the same system of axes, right? To do that, this is how the graphs are going to look, right? Just to quickly go back to the first one that we drew. Remember this, these were the values. So for us to draw the inverse, you don't need to redraw the table. You just need to swap these values around, right? Swapping them around means that 4 will now go with minus 2. So my positive 4, which might be somewhere here, will go with minus 2, which will be somewhere down there if I'm using the same Cartesian plane. My 2 will go with 4, which maybe will be somewhere there. So it will roughly be something like this, right? But the proper one that is actually drawn to scale is this one that I am showing you here. Now, as you can see, what can we notice about this graph? The original, which is the f of x, right, is a function, right? This is a function. Remember I said function is fxn, right? It just means function. But with this one, which is the inverse, what about it? Is it a function or not? I want you to quickly think about that, right? Yes, I know exactly what you are thinking. What we know about this, you need to know that this is not a function. Why? Because a vertical line will cut the graph in 2 points as it moves from left to right. So as you can see, it will be at that point and that point, this point and that point, this point and that point, right? So you can see this is moving from left to right with my arrows there, right? So if this is my vertical line, it touches at 2 points. This is my vertical line, it touches at 2 points. But now what will we need to do? We will need to do what we call restricting the domain of this function. To restrict the domain, guys, simply means that you are focusing on one arm of this particular parabola, right? Either the left arm means it's when you talk about x being less than or equal to 0, or you are talking about the right arm, right? The right part. And the right part will be when x is greater or equal to 0. That's the restriction. This is a very useful technique in trying to make the inverse of a parabola to be a function, because the goal is to always have the inverse to be a function, or else it's not an inverse, because only when it is a function can we then have an inverse, right? So please make sure you understand that. Now, as I said, it will be the right branch and then it will be the left part of the graph, which is the same as the left branch. Now, to do this, when we talk about restricting it only to have the right branch, you can see this arm, right, will be the parabola, right? The arm of the parabola. This one does not exist anymore, as I've shown you, as a dotted line. And this will not exist. Why? Because the domain of the original will be x is greater or equal to 0, right? And remember that the domain becomes the range. So it means y will be greater or equal to 0. And y greater or equal to 0 is above the x-axis, which is at this part there, right? And then I will have, when my range is also y is greater or equal to 0, my domain will be x is greater or equal to 0. So what do we know about this? If we restrict it to this, then the inverse is a function. Why? Because the line is now touching only at one point, there. Because remember, this arm does not exist anymore, and that arm does not exist anymore. If we restrict it in the other side, which is the left part of the parabola, what we know about this is it will be x is less or equal to 0. And for this graph, it will only be the left part that is there, right, which is drawn. So this will normally be, the range is x is less or equal to 0, meaning y will have to be less or equal to 0. And then the range for the original will be y is greater or equal to y is greater or equal to 0, and therefore it simply means that our x will have to be greater or equal to 0 for the inverse function. So you can see that y is greater than 0 there because it's a positive, and then x is less than 0 because it's a negative. But with the inverse, the y is a negative, hence it's less than 0, and then the x is a positive, hence it's greater than 0. So to restrict this, then we will talk about this function being an inverse, right? Why? Because as we move from left to right, we are only intersecting this graph at one point, and the inverse is only intersected at one point, no matter how long or no matter how far you are going on the graph. Just remember that there's arrows there to show that the graph will continue indefinitely. So what is actually important here about this restriction, right? This restriction that we are talking about here, the first restriction, right? I just want to go to this. So these two restrictions, you don't necessarily need to have both, right? So you do not need to have both. You must choose one, both, right? You must only choose one between the two. It's either you choose the positive one or you choose the negative domain. And that's how you then try and look at the concept of restricting a domain. Because the only time you can have the inverse of a many-to-one function as a function is if you restrict the domain of the many-to-one function. And that's how you look at the inverses of many-to-one functions. Hi guys, welcome back to our lesson. So we are still looking at the concept of whether functions, or rather inverses, are actually functions, right? Just remember that for us to talk about a function, it needs to adhere to a one-to-one or a many-to-one. But we realize that when it's a many-to-one, the inverse will not be a function unless you restrict it. So now what we are going to do is to apply all of this to questions now, to try and see exactly how do we apply this whole concept of an inverse. And these questions are questions that are adapted from past papers that we have out there. So just please follow me here. Wherever you do not understand, you always have the right to go and investigate it, please. So let's have a look at the very first question. So the first question says the following equations are given, and the equations are f of x is equals to a log Immediately I see this, I'm already thinking the inverse will be the exponential graph, right? Already I'm thinking about that the inverse of this will be the exponential graph. And then g of x will be the hyperbolic function. So now we need to sketch this, but before we do that, they tell us, excuse me, that we need to label our intercept with the x's. So to do that, we first need to find the intercept, right? So I will say here I want the x-intercept, x-int, meaning y is equal to 0. So you can see this will be 0 is equals to log of x base 3, and then this will be x is equals to 3 to the exponent of 0, and then x will be equals to 1. So in simple terms, this will be 1 and 0, all right? And then what do we know? We know that for the y-intercept, it means that our x needs to be 0, and this cannot happen, right? So we can't have this x as a 0 because there's no base and exponent that will give me a number that is 0. So this is undefined, right? So already I know this is one important point. And if this is undefined, it simply means that this is the asymptote of the graph, right? And the asymptote of the graph will then be x is equal to 0, right? So meaning it does not cross on the y-axis. Now with this hyperbolic function here, I will also find firstly the y-intercept, meaning my x-intercept, therefore my y equal to 0. So this will be 0 is equals to 1 over x minus 1. You can see I will need to cross multiply, so this is simply no solution or undefined, right? But the y-intercept will then be x is equal to 0, which will simply be y is equals to minus 1, because it's going to be 1 over 0 minus 1, you see. So what does this tell us? It tells us that this one here is our asymptote, right, which is the y asymptote, and that is y is equals to 0, right? And then our x asymptote will be x is equals to positive 1. Now, to go about drawing this, this is what you're going to have, right? So the first thing to do, remember, is always to firstly draw your asymptote, which I wanted to show you how to go about drawing it, and then you label it x is equals to 1, right? And then the y asymptote is just y equal to 0. You don't need to show that because it's on the y-axis, it's on the x-axis. And then for the exponential, just remember, or the logarithmic function, x cannot be 0, meaning it must be, x must always be greater than 0, because it cannot be 0 since it is the asymptote. So it can only be on the right-hand side. Hence, you can see my arm is just there. It does not cross to that side, or it does not cross on the y-axis, although my line seems, or my curve seems to be crossing. Now, determine the equation of the inverse of g firstly, right? What is our g? G is the hyperbolic function. So our inverse will still be the hyperbolic function, right? So remember, what you need to do here is to interchange these things. So it will be x is equals to 1 over y minus 1, and then this will be the same as y minus 1 equals to 1 over x, and then y will be equals to 1 over x plus 1, right? So already this will be my equation. And let's just quickly see, they did not specify which form, and they just said y is equal. So you can leave it as y equals to, or you can leave it as g to the minus 1 x is equals to. And then determine the equation of the inverse now of f. F is a log, right? Just remember, if it's a log, it means the inverse will be the exponential graph, right? So to do that, still, you interchange the values. So this becomes x is equals to log of y base 3. By the way, guys, for those that are wondering where I'm taking these formulas from, let's just quickly go here. I'm just simply talking about that formula there, right? So that's where it comes from, just so that I don't confuse people and you think I've introduced a new formula. And then just remember to always label this. Guys, I promise you, it will really serve you a great purpose if you do. So this is normally our exponent. We know this is our base. We know this is our number, right? So in simple terms, this will just be our number, which will be y is equals to, and then our base, which is 3, and then our exponent, which is y, is x. And then this will be the inverse function. So with these two things that we've looked at, just remember the main thing here is to always interchange. By the way, there is a mark for you to do that. Firstly, interchange them. I mark that because that means you understand what an inverse is. Your simplification, there's a mark for that. And then your answer, there's a mark. So at times you get 2 marks for the swapping and the final answer, or 3 marks for the swapping of the interchanging of the variables, the simplifying or your method, and then lastly for the final answer. So it's an either or. It depends on how much work you need to do there. So please remember, you start by interchanging them. I am not just doing it so that I remind you. No, it's because you need to do it so that it is clear on what you are trying to do after that. And then we are required to now sketch these graphs, right? And these graphs are the inverse functions. So quickly, just to show you this, I'm now going to take the concept of the intercepts to try and talk about this. Why am I saying the intercepts, right? Remember that we said x cannot be 0 because it gives us an error, right? So it means for the inverse, this is going to be error and 0, right? Because you swap them around. And then this one is 1 and 0, so it means for the inverse, it will be 0 and 1. Right? And then lastly, the asymptote here, remember we said it was x equal to 0. It means the asymptote here will be y equal to 0. So how you draw this graph, excuse me, remember the original function was that one there where it was intersecting at 1 there. This will also intersect at 1 on the x-axis because you're going to swap them around. Oh, the original was this one, I mean. The dotted line one, and then the blue one is actually the origin, the inverse function. So let me just erase this so you can see exactly what I'm talking about, right? So I'm just doing them individually so you can see, and then at the end, it will be both of them in one plane. And then the second one was this one here, right, which is g of x and the inverse. Our y asymptote was 0 and minus 1, so it will be minus 1 and 0. And then our x-intercept was error and 0, so it is going to be 0 and error, 0 and error, right, because x cannot be there. And then our asymptote here was y equal to 0 and x is equals to 1. And then our asymptote here will be y or x first is equals to 0 and then y is equals to 1, right? And then quickly on the Cartesian plane, it will look like this, right? So firstly, remember it was 0 and minus 1, which was somewhere there. And then it was 0 and minus 1, which was down there, I mean. And then it was the asymptotes that we had, which was y is equals to 0, meaning y is equals to 0 will be on the x-axis, and then x is equals to 1 will just be simply there, right? There. So the dotted line will be the original, and then the purple one will be the not the asymptote, the inverse function. And then if you draw both of them, then this is how these two graphs are then going to look. The only thing you just need to make sure that you are aware of is how to switch the things around so that it makes sense on what exactly you need to do. Guys, I hope you are enjoying this and you are seeing how this can be asked in context now, right? Because we've been talking about general terms. This is what an inverse is. This is what a function is. Now we are looking at the actual questions just to see how to actually talk about these functions. But for now, I want to take a quick ad break. When I come back, I will then look at one more question that we're going to look at that is adapted from the past papers. Please stay tuned. I'll be back just now. Hi guys, welcome back. So we are still looking at functions and their inverses, guys. I really hope that you've been learning a lot and you already have some questions that you're gonna go back and really look at using your textbooks, the internet, and even your teachers at school. Ask them questions. Don't only believe everything that we tell you. Please question it so that it can make sense to you. Because if you just take it as is, it means you are just cramming it, right? So always just try to question what you are being told, especially if it's a new concept. Anyways, let's just look at the last question that we need to look at now. It's also a question that is adapted from the past papers. We're going to answer this question and then see some theory that we need to throw in there. I will be going through that as I'm trying to solve the question. So let's look at what it is all about. So they're saying here, the sketch shows f of x equal to ax squared plus bx plus c, and g of x is equals to that, right? And both these two graphs, they pass through that particular point. This is very important, guys. I promise you, there is no way that you can do a graph and they don't tell you which point the graphs are passing through. Firstly, we need to find the value of a, b, and c. To do that, we're going to use the equation y is equals to a into x minus x1 into x minus x2, right? Let's quickly explain what this formula is all about. This x1 and this x2, these are the x-intercepts of the graph, right? And the x-intercepts are normally seen where the graph is intersecting with the axis, which is at 2 and 4 in terms of this graph that we have here, right? And then we don't know what A is because all the three letters need to be found. So I'm just going to substitute my x-intercept and then substitute the point that I was given. So this will be y is equals to a into x minus x1 into x minus x2. That's the very first thing I need to do. You substitute y is equals to a into x minus, this is 2, and then x minus 4, right? And then I have a point 1 and 3, so this will just be y is equals to, not y, because already I'm substituting what that is. So this will be 3 is equals to a into 1 minus 2 into 1 minus 4, right? And then this will be 3 is equals to, my a here will be 1 minus 2 is minus 1, minus 3 is a positive 3. So this will be 3a, and therefore a is equals to 1. So already I know I can say y is equals to 1 into x minus 2, x minus 4. If you FOIL this out, then it will give you your A, B, and C. Already we know A, right? We just need the B and the C. So this will be y is equals to x squared minus, this is just going to be 6x, and then lastly it will be plus 8, right? By the way, I hope you guys are clear on how to go about foiling this. I know by now you need to be familiar with that. It will be A is equals to 1, then B is equals to minus 6, and then C is equals to 8. Because you will need to write them down, because the question wanted you to determine the values, right? So 1 minus 6 and 8. So let's just remember it's 1 minus 6 and 8. I will be writing them as we move along so that we are clear as soon as we need to use the equation. Now we need to find the value of k. You just need to substitute the point now here. You just need to substitute the point, right? So to substitute the point, or before we look at the inverse, substituting this point, it will be 3 is equals to k to the exponent of 1. So k to the exponent of 1 is just k. Therefore, k is just equals to 3, right? Now, 1 minus 6, 8, and 3. Now, there's more things that you need to remember. So this is positive 1 minus 6, 8, and then this is going to be 3, right? Now, if h of x is equals to the inverse of g of x, we need to write down this equation, right? H of x is the inverse of g of x. Just remember, to actually go about doing this, you need to interchange. So y equals to x. So this becomes x is equals to 3 to the exponent of y. And then remember to label your points. This is my exponent, and this is my base, and this is my number. And you know, just to remember what a log is about, it's exponent equal to the log of the number and then the base down there. You see, so you just need to please remember those. So this simply means it will be y is equals to log of x base 3, right? Some people claim that you just write y is equals to log and then you drop this, right? You just make it a bit low. That's just cramming, guys. Please don't try and think about such things, right? Although, yes, it's a shortcut, but it does not give you the sense of where does this come from. So please make sure you understand it's all about reflecting about the line y equal to x. And then you need to determine the range of f of x. Remember, the range of f of x, this will be the y values, right? The y values. And the y values of this normally start, right? Because this is a happy face. Remember, this is 1 minus 6 and then 8. So this is a happy face, as you can see. This is normally the minimum value, right? Which is y minimum. So in simple terms, our range is always going to be y is greater or equals to the minimum value at all times. So we quickly need to find what our minimum value is here. And to do that, we need to find the turning point in simple terms, right? So what do we know? We know that our, since it's 2 and 4 there, our x value there for the turning point will just be the average of those two values. But the proper equation to do this will be x is equals to minus b over 2a, and this will be equals to minus into minus 6, and then over 2 into 1, and this will simply just be 3, right? And then now I need the y minimum value, so I must substitute the 3. So to do that, this will be f of 3, which is equals to 1 into 3 squared minus 6 into 3 plus 8. Just remember the values of A, B, and C, right? And this 3 squared will be 9, minus 18, because 6 times 3 is 18, that will give me minus 9, then plus the 8 there will give me minus 1. So my range will be y is greater or equals to minus 1. So let's quickly just talk about this. For me to find the range of a parabola, I need the turning point of the parabola. The turning point, I don't need the whole thing, right? It's just unfortunate that I can't really find the y turning point without getting the x turning point, unless I complete the square, but that's a longer process. So you just find the x turning point, substitute it, get the y turning point, and then you are fine. So if it's a third phase, it's y is less or equals to the maximum point, which is normally the turning point value of y. And then if it's a happy phase like this one that we just have now, it will be the minimum. So from the minimum going upwards, that will be my range. And then you know, domain is always just the concept of x is an element of real numbers. So let's just look at a few other questions that we quickly have here. We need the axis of symmetry of this, right? So remember, the axis of symmetry of the graph is normally going to be given to us as x is equals to minus b over 2a, which you would have done in the previous question, which is just 3, right? So it's normally x equal to 3. You write it as an equation, right? So please just remember that. Now explain why the inverse of f of x is not a function, right? Remember, the reason for this is because a vertical line test, right, line will cross the graph at 2 points, cross or intersect. Let's actually use the mathematical terms, which is intersect the graph at 2 points, at 2 points, right, as it moves from left to right. That's why it's not a function, right? Because it's just going to be something like this. So if you draw a vertical line, it will be at that point and at that point. Now, what do we now need to do in order to make it the inverse to be a function? Then what you will simply need to do is to restrict the domain, right? So it will be to restrict your domain, which is the x, restrict x, right? That's why they are specifically asking you about the values of x. So in simple terms, this will be either x is going to be greater or equal to 0, or you can say x is less or equal to 0. You can choose either one of the two. Now, just to summarize what we've looked at, guys, this is a relation that can be considered a function if one input value has exactly one output value. And then an inverse is normally obtained by reflecting about y equal to x. And then remember, a graph can only have an inverse if it is a function. Guys, this is really, really, really too much information that I hope you manage to take down, and you will be able to use it at a later stage. But from me to you, remember, this is the end of our lesson. I've looked at the concepts and what they are all about, and then some questions from this. So please try find more questions, apply what we've looked at, consult your textbooks, your teachers, and the internet itself. But from me to you, remember, mathematics is food for the soul. Until next time.